Now our second chapter is polynomials. We studied the same chapter in class 9 as well. Polynomials is second chapter in class 9. So in this chapter little more you are going to study about it. Okay. So first of all let us revise what we learned in class 9. Okay, some revision. Is the definition. It's not required actually. You have already learned. What is polynomial first of all? Should know what it is. Algebraic expressions. Suppose I talk about a polynomial in any variable, x, y or z, commonly used variables. So I take x as a variable here. The expression, algebraic expression in x is called a polynomial in x. If it is y, it will be a polynomial in y. When, under which circumstances? What is the condition? An algebraic expression in x is called a polynomial in x if the exponents or powers of x are non-negative integers. Means all the powers of x in each term you have to check. Power of x or exponent of x must be non-negative integer. Means it may be 0, 1, 2, 3 like that. Should not be negative or fraction should not be there. Okay. So the powers of x are non-negative integers, then we call such expressions we call as polynomial in x. Alright. The examples already you learned. See, 4x square plus 3x plus 9. I check in each term what is the power of x here? 2. Non-negative integer, whole number. In other words, x power, x means x power 1 only. Here no x, so it is some 9 x power 0 you call. X power 0 is 1, 9 into 1 is 9. So here all the terms, power of x is non-negative integer. I did not give any example for what is not polynomial. Already learned. So that is why. Okay. I have to check in each term, power of x is non-negative integer. If not, it will not be called polynomial. So okay. Here root 3, root 3 times x. Here root 3 is what? Root 3 is only coefficient. You are checking only the power of x. So power of x is 1 here. Power of x is 0 in this term. So power of x in both the terms are non-negative integer polynomial. Like that here, x cubed coming, 5 coming, 5x power 0. This is coefficient 2 by 3. 2x also polynomial, x power 1. 15, only an integer I have taken, any number, any real number I took. Here no x, so x power 0. Okay, it's a constant polynomial, there is no x here, so we call x power 0. Let's go to the other one. Degree of a polynomial. Degree of a polynomial. This is the second thing we studied there already. What is the degree of the polynomial? The highest power of variable involved in the polynomial is its degree. The polynomial's degree. Highest power of variable involved means x. What is the highest power of x? That is the degree of the polynomial. Few examples are written here. Is also here. 5x plus 2. The highest power of x is 1. We don't put x power 1. We write x. So degree 1. This is how do we call? A linear polynomial plus 9. Okay. Again on 3x square plus 4x plus 5. What's the degree? Highest power of x 2. Degree 2. We call how? Quadratic polynomial. Here. What is that? Here x cube times x terms are not there, still no matter. Highest power of x here is 3. So degree is 3. Cubic polynomial. Here. 5 highest power of x. Polynomial of 5th degree polynomial. Polynomial of degree 5. No special name there. Okay. Here what? Degree 4. People call biquadratic polynomial. Okay. Biquadratic polynomial. So, if a constant is there, what it is? So I take a number 75, the degree is 0. Okay, degree is 0. Constant polynomial. Okay, so order. Like that 0 polynomial also you will learn. If all the terms in a polynomial are 0, that we call 0 polynomial. What can you say about the degree of the 0 polynomial? Class 9, let us revise. There is no degree for 0 polynomial. Not defined. Degree of 0 polynomial is not defined. All we learn. Okay, here let us see the general form, standard form or general form of all these kind of polynomials. Usually instead of we replace the numeral with a, b. These are the real numbers. Okay, any constant. So ax plus b, so degree 1. X is a variable. A and b are real number, constants they are. Ax plus b, where a and b are real numbers, a not equal to 0, the general linear polynomial. General linear polynomial. Why a not equal to 0? I told you a is a real number. 0 is a real number. Suppose I put here a is equal to 0. This x term won't be available there. 0 times x, no x. It will work like constant. So this coefficient of x should not be 0. This can be 0 no matter. For example, you learn here 2x or 5x. 5x is a linear polynomial. This constant term is not there. So like this. So b may be 0, but a should not be. Right. Ax square plus bx plus c. Ax square plus bx plus c. Where a, b, c are real number. Any real number. Maybe rational or irrational, no matter. A should not be 0. Coefficient of x square should not be 0. Otherwise it won't be quadratic. Okay. So this is general form of a quadratic polynomial. Ax square bx plus c. We usually take x square coefficient as a and that of x is b and constant term we take c. Like that ax cube plus bx squared plus cx plus d, where a, b, c, d are real number, a not equal to 0, general cubic polynomial. So general form of linear polynomial, quadratic, cubic, biquadratic, ax power 4 and so on and on, like that. So clear now? It's just only revision. Some more we do in class 9 portion revision, then we'll enter into class 10 portion. Yes. The value of a polynomial is also we studied in class 9th. Polynomial in x, p of x. What is this value? You know, p of x I have taken x square plus 4x minus 9. It's a statement, you know, expression in x. I don't know what is x, variable. It changes. So if they are given, if I am given the value of x, what is the value of the variable? I can tell what is the value of the polynomial. So all I have to do is, I have to substitute the variable's value in its place in the polynomial. The question is finding the value of px at x is equal to 1. So where x is coming, I substitute 1. This p of x means a polynomial in x, you know, we denote like that. The p of x. So I substitute x is equal to 1, p of 1 is equal to 1 square plus 4 into 1 minus 9. Simplify, I get minus 4. So the value of polynomial px at x is equal to 1 is minus 4. If I am given some other value x is equal to 2, I substitute x is equal to 2. That's all. So that is the value of the polynomial at the given value of the variable. At the given value of the variable. For different values of the variable, we get different value of the polynomial. That's all. Other examples, the polynomial in y, another variable, p of y is equal to y cube plus 3y square plus 2. At y is equal to minus 1 they ask. So I substitute p of minus 1 I get. I get here 0. And I substitute y is equal to minus 1. This is becoming 0. Okay. Next you are going to learn 0 of a polynomial. This is also class 9th portion. What is 0 of a given polynomial? Means at which value of the variable, okay, at which value the polynomial vanishes, the value of the polynomial vanishes, becoming 0. That value of variable is a 0 of the polynomial. For example, this example you see. I substituted y is equal to minus 1. What happens to the value of the polynomial? 0. So this particular value of variable y is equal to minus 1 is called the 0 of the given polynomial. Is that clear now? If I put y is equal to plus 1, it will not become 0. If you substitute y is equal to 1, I won't get this number as 0. I will get here 1 plus 3, 5 plus 7 I will get. Means 1 plus 3 plus 2 means 4 plus 2, 6 I will get. So it's not 0. So y is equal to minus 1 when I put, it is becoming 0. So y is equal to minus 1 is the 0 of the polynomial. Okay. Like that here few examples have been taken. So the value of x at which p of x becomes 0 is called the 0 of the polynomial. Example here p of 2 they gave me this polynomial. I put x is equal to 5. So p of 5 is here what? 10 minus 10 becoming 0. So x is equal to 5 is the 0 of the polynomial. This is all we learned before. How to find this number? Why should I put x is equal to 5? Are all coming later. It's all already in 9th class. Come to this one. See, this is a quadratic polynomial. Quadratic polynomial p of x. P of x is equal to x square minus 25. They gave me a quadratic polynomial E2. Okay? So here I just substitute x is equal to 5 here. So I get 5 square minus 25. 25 minus 25 becomes 0. Now I substitute x is equal to minus 5. Then also it is becoming 0. Because minus 5 the whole square minus 25. Minus 5 the whole square is 25. So 25 minus 25 becomes 0. Okay. So minus 5 if I put also it becomes 0. So there are two values of x at which the polynomial's value vanishes. X is equal to 5 and x is equal to minus 5. So I get two zeros for this. There are two zeros for this polynomial p of x. Right? Come to this one. This is also linear polynomial. It's a quadratic polynomial. Maximum there will be two zeros. Maximum. There may be one zero also. There may be no zero also. We'll come to that all later on. Let's come to this one. P of x is equal to 4 of x. 4x. 4 times 6. Here what is the 0 of the polynomial? The substitute x is equal to 0 here. In the place of x, if I put 0, then only it will become 0. So 4 into 0 becomes 0. So the 0 of p of x is 0. X is equal to 0 is the 0 of this polynomial. So different polynomial, we have seen that. Next, how do we find the 0? Especially for linear polynomial. In 9th class we studied for linear polynomial only. Let us take the polynomial p of x is equal to 4x plus 5. I want to find out what is the 0 of this polynomial. Means what value for x I have to give so that this whole thing becomes 0. So how do we find out? Little harder to find out. Here you cannot guess and do it. You are not able to guess and do. So what I actually have to do, you take the polynomial vanishes. Means you are taking the polynomial became 0. Means 4x plus 5 equal to 0 you put. Okay? Then find out what might be the value of x. So if I substitute the polynomial, if I equate the polynomial to 0, then it will become a linear equation. Linear equation. Solve for x. Find out what is the value of x. It's coming x is equal to minus 5 by 4. X is equal to minus 5 by 4. So this is the 0 of the polynomial. You substitute in the place of x, put minus 5 by 4 here, the whole thing will become 0. This is how we learned in class 9th how to find the 0 of the polynomial. You take the polynomial, let the polynomial vanishes, means equate the given polynomial to 0 and you get an equation, linear equation. Solve for the variable x. Okay, this is how we can see more examples and then we will move to the other topic. Let us continue with other examples. Take the general linear polynomial. P of x is equal to ax plus b. For a and b are real numbers, a not equal to 0. Same procedure follows. So ax plus b equal to 0 you put. So ax is equal to minus b, x is equal to minus b by a. So the 0 of the general linear polynomial is x is equal to minus b by a. Minus b by a is the 0. Right. Same way other examples. P of y, P of x, okay. Here P of x is given to be minus 4x. So minus 4x is equal to 0. If I put what is x coming? 0 by minus 4, x is equal to 0. So x is equal to 0 if I put, then only the polynomial's value will vanish. So x is equal to 0 is the 0 of this polynomial. 0 of this polynomial. This is what all we studied in class 9th. Okay. The introduction we have given with the class 9. What we are going to study in class 10 about the zeros of quadratic polynomial. How to find the zeros of a quadratic polynomial. What is the geometrical meaning of zeros of a polynomial and cubic polynomial. What is the relationship between zeros and coefficients. In this way we continue chapter to polynomials in class 10th. Okay? Alright. See, now let us see if you have chosen some quadratic polynomials. Okay, factorizable ones. To find the zeros of the quadratic polynomial, you will be given a quadratic polynomial and to find the zeros. As I told you, a quadratic polynomial will have a maximum of 2 zeros. Okay, some quadratic polynomial do not have any zeros. That also we will discuss later. Let us take this polynomial. P of x is equal to x square plus 5x. So what you have to do here, for what value of x this will vanish, we do not know. So what you have to do, you have to follow some steps here. First you will factorize it into linear factors. The quadratic polynomial, if possible, factorize it into linear factors. Okay? If factorize into linear factor, you get 2 linear factors. Each linear factor equal to 0. Then each one will become the question like this one below. We have done here now. 2 linear factors, each one will be coming like this. So then you equate each linear factor to 0 and get the value of x from that. This is the method. Factorize into 2 linear factors, equate each to 0 to obtain a pair of linear equations. Once I am equating to 0, it will become linear equation and solve for x. Find the value of x from that. Okay, this example, x square plus 5x, how to factorize? There are some methods of factorization. If it is a binomial, you can look for any common factor. You take the common factor out, then factorize. Sometimes in this type of questions you will have to use common factor, but still you can factorize using identities. A square minus b square, that kind of identity. These are the examples we will see. See the first example, x square plus 5x. So I take common factor out. What is the highest common factor here? X that I taken out. What is inside the bracket is x plus 5. I got 2 linear factors. The first one is x, the other one is x plus 5. Each one equal to 0 as we did before. So x I equal to 0. So x is 0, that is one value, directly came. The second factor, x plus 5 equal to 0 and find what is x. X will be minus 5. So x is equal to 0 and x is equal to minus 5. For both the values, this polynomial will vanish. Okay, x is equal to 0 substitute, it will become 0. X is equal to minus 5 you put here, still it will become 0. So these are the 2 zeros of this quadratic polynomial x square plus 5x. The next example, x square minus 25. Here is the binomial. How to factorize? You have to use identity. No. Should use the identity a square minus b square. In this form you have to make it. And its factorization a plus b into a minus b. This way you have to make here. Because there is no common factor between them. No. So you have to take what? So no common factors. So how to factorize? Look for identities. So write x square minus 5 square. 25 is 5 square. So right, apply this identity. A square minus b square is equal to a plus b into a minus b. So x plus 5 into x minus 5 I get. Equate each one of them to 0. X plus 5 is 0. So what I am getting, x is equal to minus 5. The second one, x minus 5 is equal to 0. X minus 5 equal to 0. X is equal to 5. So there are two zeros you are getting. X is equal to minus 5 and x is equal to 5 are the zeros of this polynomial. Is that clear? Suppose if it is not a perfect square of this kind, if you are giving x square minus 3, don't have to worry. So write what? X square minus 3 is square of root 3. Write that 3 as root 3 square. Root 3 square. Again apply the same identity. A plus b into a minus b. So it will become what? X plus root 3 into x minus root 3. Two linear factors came. Equate them to 0 each one. So x plus root 3 is 0. Getting x is equal to minus root 3. Like that, x minus root 3 is 0. So x is equal to root 3. So two zeros. Minus root 3 and root 3 are the zeros of the given quadratic polynomial. It is binomial. Whenever it is binomial, look for common factor. There is no common factor. Try to use identity a square minus b square. Then it is factorizable. Okay. If it is given x square plus 25, then you cannot factorize it. Minus 25 given, you are applying the identity and factorizing it. So question is given x square plus 25, we cannot factorize it. Okay. And doesn't have zeros. We will discuss later. Come to this only. 2x square plus 5x minus 3. Trinomial. This we learned already in class 9. You know how to factorize it. By splitting middle term method. Here I have splitted here. Sum is 5 and the product is 2 into minus 3. So minus 6. So split the middle term as 6 and minus 1 are the numbers meeting it. So 5x will be 6 and minus 1x. In that way, if I take common factor, I can take it out from the first two and the next two common factor take out is all our 9th class matter. So factorize it into two linear factors like this. Each one equal to 0, x plus 3 equal to 0, so x is minus 3. Like the 2x minus 1 is 0 if you put, x is equal to half, transpose and find, x is equal to half. So these are the zeros of the polynomial. Is that clear? Like that here, sometimes it will be, you can use the identity also. See this question, x square plus 6x plus 3. You can use splitting middle term also, any method. Like I am using here identity because it's a square of 3. So a square plus 2ab plus b square. In that form I wrote, I get x plus 3 the whole square. X plus 3 into x plus 3. If you factorize by splitting middle term, you are going to get the same thing. X plus 3 into x plus 3. Each linear factor equal to 0. Here x is equal to minus 3 and x is equal to minus 3. What do you say? Both the zeros are same number here. Okay? Equal zeros. These two zeros are same number, nothing but the same number. Equal zeros here. These are the ways we will find out. Means we have to just factorize it into linear factor. Equate each linear factor to 0. You get two linear equations. Solve them for x. What value of x2, values of x we get? Both are called what? Zeros of the quadratic polynomial. Here I have written some 3 examples. Note down these 3 example questions as homework. Okay? You can try at home this one, these 3. The next topic we will discuss.